All right, guys, I figured that you might need a little more guidance with these word problems than you were able to get in class. So I'm going to walk through in each of these word problems just the setting up of the equation, and then you guys, I think, can handle it from there. So in every case, the thing that matters on these problems is you're always going to take a rate alone plus the rate for somebody else alone plus however many are in there equals the rate they can do it together. That's going to be our basic premise. Now, as we get into some of the different problems, we might not be doing that. But let's take a look and see. So with Hannah and Walter, I'm always going to let my variable represent the thing I'm trying to find. So at the end, it says, how long will it take to fill the pool using only the large hose? So that means X is going to be the time for the large hose to do it alone. So now I'm going to set up this equation. Let's see. 2 hoses together did the pool in 9 hours. The smaller one takes 3 times as long to fill. Okay, so 3x is the time for the small. And the 9 is the time together. So the large hose can do 1 pool in X amount of time. The small one can do 1 pool in 3x amount of time. That's the 2 alone rates. And then together they can do 1 pool in 9 hours. So now if you use your LCD, then you can take it from there and solve to get the answer. All right, let's look at, we're going to skip this one. Let's go to the problem 4, because this one's also very similar. Now, when I look at this one, the final question says, how long does it take to get the job done together? So I'm going to let X represent the time it takes for them to do it together. Now, I am going to need each of their individual times because I know that I have to add rates together, and rates are a job divided by individual time. Well, Amelia says I need an hour more than if we work together. So she says, whatever the time it takes for us to do it together, I need 1 hour more. And Reese, with her dance injury, says I would actually need 6 hours more. And Sarah, because she's really hoping to get some decent pay out of this, says it would take her twice as long. So those are their individual times. Since we don't know anything about how much sand there is, we can call it one job. So it would take Amelia 1 job in X plus 1 hours doing it alone. It would take Reese 1 job in X plus 6 hours, would be her rate. And Sarah works at a rate of 1 job in 2x hours. And we're hoping to find out what would it take for them to do 1 job together. This is going to be a pretty interesting LCD, but once you get it, you can solve and get to the answer. So now let's go back up to this one, the Lily Charlotte problem. This one gives us an important thing, and it's right here, that the exact same time in the air. It also says, what was the speed of the wind? So I'm going to let X be the wind speed. And it says that the time for Lily equals the time for Charlotte. So I know those are the same, but nowhere in this problem does it give me any information about time. I know the cruise control speed. What I don't know is the actual speed because of the wind. Well, I do know that distance divided by rate gives us time. So if I can find the distance for Lily divided by how fast Lily's plane is moving, and if I can find the distance for Charlotte and divide by how fast her plane is moving, I know those 2 answers will be the same. Well, Lily's distance I was given. That's easy. And so is Charlotte's distance. The problem is that I don't know their specific rates, and I haven't yet figured in this whole wind thing. Well, that's where I need to now go to some physics. So here's a plane. here is against the wind. And then conversely, here's a plane, and this is with the wind. You have to imagine this is just like when you've ever walked on a people mover at an airport or a treadmill. If you walk on the people mover, the same direction that the people mover is going, so this one with the direction of the people mover, you move faster than you're physically walking. So if the plane is going at 125 miles per hour and the wind is going at X miles per hour, then the sum of their speeds is how fast they're traveling together. Now, if you've walked on a treadmill, you've got the perfect thing for this. A treadmill walks the opposite way you do, it running on its belt at the exact same speed that you are walking, which is why you go nowhere. So if the plane is trying to go 125 into the wind, it's being slowed down. That means that Lily, who has the wind with her, has a denominator of 125 plus x, whereas Charlotte, who's suffering against the wind, has a denominator of 125 minus x. And so there's our equation. We just go from there. Now, the silver problem is the hardest of the bunch because we have to try to figure this all out. What we have in this problem is we have what Hannah requested and what the boys are going to mix. And we know that if they're going to get paid properly, that has to be the same. So something about what Hannah wants has to equal something that the boys put together. It says how much pure silver. So X is going to be, since I saw ounces in this problem, ounces of pure silver. So now let me think this through. I'm going to take 15 ounces of what they have. I'm going to add in pure silver, and I'm going to get what Hannah wants. So maybe what I need to do is think about this in terms of the percentages and the weights. Okay, so now let's look at percent. Since I know the pure silver, it's ultimately the copper that's going to decide the percentage. So Hannah is asking for 7.5% copper by weight. That means that 7.5 out of every 100 ounces needs to be copper. That's what she wants. So we have to figure out how to make the boys' mix come out the same. All right, so now let's keep looking at this. We got to figure out what's going on. All right, so right now, the boys have 15 ounces of 800 grade. So their 15 ounces is 20% copper and 80% silver. Since we're looking at ounces here, why don't we figure this out? 20% of 15 is 3 ounces of copper, and then that would be 12 ounces of silver. So when I look at this 7.5 is ounces of copper. This is going to be a proportion. 7.5 ounces of copper out of 100 ounces of mix has to come out to be the 3 ounces of copper that's in the mix the boys have and can't change out of a larger amount of material. The only way to knock this down from 20% copper to 7.5 is to make the denominator, the amount of mix, bigger. So the 3 ounces of copper the boys have divided by what's going to be the new amount of total mix after they add all of their pure silver to it. And so now you have your equation and you can solve from there. I hope this helps you guys a little bit more with the setup and everything of how to work these equations.